Simplifying radicals. So we're only going to look at perfect roots here, but we're going to look at different types of radicals. So what might help is creating a list of perfect roots. So if you start with squares, for example, 2 squared, 2 times 2 is 4, 3 squared, 3 times 3 is 9, 4 squared, 4 times 4 is 16. You continue that process. These are perfect roots. So these are for squares. You can do the same process with cubes. 2 to the third power, 2 times 2 times 2, that's 8. 3 to the third power, 3 times 3 times 3, that's 27, and you can continue that process. You could do it with exponents of 4 or 5, but when you see these problems, having a list is going to be helpful. So the first thing for this first problem, simplify the square root of 1/64th. There is an imaginary 2 here. So these radicals, if there's nothing written in what's called the index, that is the number 2. So this is your index, and this piece underneath is called your radicand. So if there's no index written, we say the index is 2. So we're looking for the square root of 1/64. So pretty much because this is a fraction, we want to know the square root of 1 and what's the square root of 64. And all we're doing is putting them in fraction form. The square root of 1 is 1. The square root of 64 is 8. So the answer is going to be 1/8. So the reasoning, the square root of 64 is 8 because if you take 8 and you square it, 8 times 8, that gives you 64. And that's how you do these radicals. So for the second problem, find the cube root of 64. We're looking for what number to the third power is going to give us 64. So you pick numbers. You multiply them 3 times. Same number 3 times, and it should give you 64. The answer here is +4. So we're only looking for perfect roots. So sometimes things get complicated when we are looking at negatives inside the radical. So they're pretty basic rules that are going to help. If the radicand is a negative number, you want to have a couple rules under your belt. So there's 2 different rules. You have an odd index, which is the example on the bottom, where the index is 5. And then you have an even index for this top problem, where the index is 4. So we'll do the top problem first. If there's an even index and your radicand is a negative number, in this case, the number inside is -81, it will result in an imaginary root. So this does not represent a real number. This is not a real number. So depending on the math class that you're taking, some courses accept this as an answer. You're done, don't worry about it. Other courses, when you get more involved, these lead to imaginary numbers. So depending on what class you're in, it's either not a real number or you have to actually do math to get an imaginary number. So for the odd index in that second problem, it's actually going to result in a negative answer. So you're still going to get an answer. The fifth root of -32 is -2. That would be the answer. So the reason, if you take -2 and you raise it to the 5th power, it's going to give you -32. -2 times -2, 1, 2, 3, 4, 5. So these two, when you multiply, give you 4. When I multiply these two, that gives me 4. That's negative 2. 16 times negative 2, negative 32. So that's where that comes from. So if you're multiplying a negative number to a odd power, any odd power, you're going to get a negative number because of the rules for multiplying and dividing integers. So that's how you simplify all types of radicals with numbers, regardless of what the index is.